So we've talked about limiting reactant before, and this is just a quick video to show you what that calculation will look like. Limiting reactant is an ingredient that you run out of, and it prohibits you from producing any more product. So it's going to limit the amount of product you make. And so there are a couple things that they could ask for. They could either ask, in this particular situation, which ingredient is consumed first, so which one keeps us from making more product, or they could ask us which is the amount of product that's actually produced given these two starting amounts. The method I'm going to show you will answer both questions, and so you just need to know where to go, which part of the answer to point to based on the question that's asked. So we're going to begin with our amounts of each 4.1 grams of chromium and separately 9.3 grams of chlorine. Now it's our job to turn both of these reactants and calculate how much product that can be produced. If there's more than one product, here there's only one, but if there's more than one, make the product that they want to know about. So we're going to make both of these into grams of CrCl3. We do this the same way that we did our gram-to-gram stoichiometry problem, because in order to switch from one substance to another, we need to know the ratio that their particles combine in. And so we need to have moles for that. So to go from grams to moles, I need to divide by the molar mass, in this case, of chromium, which happens to be about 52 grams. In the middle step, we're going to use our mole ratio, and we always put the substance that we want to end up with in the numerator, our starting substance in the denominator, and our mole ratio is going to be moles on the top and moles on the bottom. It's just moles of our starting stuff on the bottom, what we want to switch to on the top, and the numbers that go in the mole ratio are found in the balanced equation. They're the coefficients. So the coefficient of chromium chloride is 2, and the coefficient of chromium, in this case, is also 2. And then to finish up, we just change to grams of the product we want using the molar mass, how heavy 1 mole of this stuff is on the top. So we need the molar mass of CrCl3. So we're going to add up a chromium and 3 chlorines. So a chromium we said was 52, and our chlorines 35.45, but we need 3 of them. So that gives us 158.35. Now remember, if it's in the numerator, you multiply it, and if it's in the denominator, you divide it. So we'll do this, divided by 52, times 2, divided by 2, multiply by 158.35, and that will tell us the amount of chromium chloride that will be produced if we're able to use up all of the chromium. And that amount is 12.49 grams. Or in this case, since we only have 2 significant figures, really we should just say 12. We'll say 12.5. I don't think the person who made this problem was thinking about significant figures. Now we're going to do the same thing, only now we're going to assume that we're able to use up all the chlorine. And if we can turn all the chlorine and calculate how much chromium chloride we get from that, then we can compare our 2 answers. So a mole of chlorine, since chlorine is diatomic, it's Cl2. That's 35.45 times 2, so that's 70.9 grams. Our mole ratio in this step, we still want to put the new substance, the one that we're trying to find, on top. We're making the same substance or calculating the same product in both cases so that we can compare. So the mole ratio up there will be the same. But down here, this is different because we're coming from moles of chlorine. So we need to go find chlorine in the balanced equation. It's got a 3 in front of it this time. So here we will multiply by 2 and then divide by 3. Now, because we're making the same product, the ending conversion is identical to the one above it. So you're really only doing 1.5 problems because this portion and then these two portions are identical from up above. If you were to look at them, like if you just look at this part and compare it to this part, those pieces are going to be the same. And that's precisely because you're making the same product so that we can compare the results. So 9.3 divided by 70.9 times 2, because in the numerator, divided by 3, and then multiplied by 158.35. And so we get 13.8 grams of chromium chloride. Now, the question is how much chromium chloride is produced, and we have two answers. A lot of people mistakenly think we need to add these together. We don't. Only one of them is correct, and in fact, it's the one that there is less of. I get 12.5 grams of chromium chloride if I use up all the chromium. So the chromium's all gone when I have this amount. In other words, I don't have enough chromium to make any more. So there's no way I can do this much because I don't have enough chromium. I only have enough chromium for 12.5. So this amount is not possible given the amount of chromium that I started with. So this is the amount that is produced. If they were to ask you for which of these was the limiting reactant, it's the one that produces the smallest amount. So in this case, chromium is the limiting reactant. If I had more chromium, I could make more product, but I don't. So this is as much product as I can make. This limits the amount of my product. So if they ask you for the amount produced, you're looking at this answer, whichever one is the smallest. And if they ask you for the limiting reactant, it's the reactant, the starting stuff, that produces the smallest amount.